Something important that we have to understand, that every atom wants to achieve stability. All right, every atom wants to become stable or unreactive. In order to do so, in order to do so, they would have to achieve in noble gas. In noble gas,
सर ये दे के बाद आपने क्या लिखा है? दे
they would have to achieve a noble gas configuration. What is a noble gas configuration? Noble gas configuration can be explained in two ways. In an duplet and octet configuration. Duplet configuration or octet configuration, which means they need to have a full outermost shell that is having 8 electrons in the outermost shell, or 8 electrons in valence shell. Duplet configuration is having 2 electrons in the first shell that is also the last one. The first shell, which is also the last one, which is the only shell. If it is the first and the only shell, they need to have 2 electrons in it. And if it is the last, any shell apart from the second shell, apart from the first shell, and it becomes the last shell, they need to have 8 electrons in order to achieve stability. So these two configurations are actually called octet and duplet configurations, which is actually a is done in order to achieve a noble gas configuration. All right, this gives an electron stability, but there is a price that needs to be paid for it. Let's look at sodium. Right, sodium is 23 and it has 11 electrons and protons. Right, so in the first shell, we know you can only have 2 electrons. Then in the second shell, we can only have a maximum number of 8 electrons. This makes how much? 10. And in the last shell, we are actually counting the number of electrons, right? In the first shell, we can only have maximum of 2 electrons, right? In the second one, we can have maximum of 8 electrons. In the third, how many are left? Only 1 electron is left, right? It makes sense, right?
Yes.
So this is how actually we write the electronic configuration. How do we write the electronic configuration? We write the number of shells and the electrons in each of those shells, right? Something that we have to keep in mind over here is that the shells, they fill up after one another. The innermost will fill first and then the outer ones. Do you understand? Each of these are representing one shell. Shell,
सर ये द द के बाद
shell,
क्या लिखा है?
shell. कहाँ पर?
जो सेकंड पॉइंट है नीचे.
The
द
innermost will fill first and then the outer ones. The outer ones and then the outer ones. So let's say if you have nitrogen. Nitrogen, how do you write? What is the atomic number? Atomic mass of nitrogen is what? Any idea? 14.
14 सर.
The atomic number is 7, which means it has 7 electrons, 7 protons, and neutrons. 14 minus 7 is 7 as well. So if you want to draw the electronic configuration, we are going to be drawing the first shell. Obviously, we know that you cannot have more than 2 electrons in the first shell. Then how many of them are left? Rest, you can only get 5 more electrons. So we know that the nitrogen has only two shells, first shell and the second shell. It only has two shells, and we know that shells represent the periods. We will learn. I just want you to know this right now. We will learn about it later, inshallah. So this, it means that this is the 5 electrons are the valence electrons, because this is the last shell, and the last shell is always the valence shell. Is this clear? Are you getting the
Yes.
point?
Yes.
It is this last shell which actually needs to get an octet configuration. It needs to have 8 electrons in it to become stable. This is what we have been doing up till now, right? So how is this, all of this is possible? What happens is, if you look at sodium over here, if you look at the case of sodium over here, it has 1 electron in its outermost shell or the valence shell, right? It is extremely difficult for it to get 7 electrons. Plus,
Yes.
metals are not good acceptors of electrons. They are good donors of electrons. It is difficult for them to gain 7 electrons. So what is it going to do? It is going to give off an electron to achieve the octet configuration, and it is going to be left with 2 and 8, which becomes its last shell, and the shell that has 8 electrons in it. Do you get it?
Yes.
And it achieves the stability, but it comes with a price. The price that it has to pay is that its protons are 11 but electrons are 10. So it is going to get a charge because an electron has left. So there is an uneven distribution of charge now, which is, this is the price that it has to pay, becomes an ion. Do you understand?
Yes.
Similarly, if you look at the case of nitrogen over here, nitrogen,
सर यहाँ पे आपने कहा कि इलेक्ट्रॉन लेफ्ट किया, तो फिर ये 8 कैसे हुआ?
देखो ना, ये वाला इलेक्ट्रॉन चला गया ना, दिस इलेक्ट्रॉन इज गॉन ऑलरेडी. ये जो लास्ट शेल में
हाँ.
इसके इलेक्ट्रॉन था, इसकी कॉन्फ़िगरेशन क्या थी सोडियम की? सोडियम वाज 23 and 11. It has 11 electrons, है ना? Which
जी.
means 2, 8 and 1. So this, it had to either get 8, it had to either get 7 electrons in order to become 8, or the other option is that one of the electron leaves. Which is better? that one of the electron leaves.
One of the electron
When one
leaves.
of the electron is going to go away, the shell is going to finish because there is nothing anymore left. Shells are what? Shells are just imaginary lines where the electrons are found. अब जब इसका
Yes.
electron चला गया है तो there is no more shell, so it is only left with two shells, this one and this one becomes the last shell. The second shell has now become the last shell and it is full, right? It is full. This being full is actually has given sodium its stability, but it has to pay a price. It has become an ion now. This is what we are talking about. You get it? So
Yes.
this ion of sodium has 23 atomic number, but the number of electrons that it has, the number of protons is still the same, 11, but there are only 10 electrons and 12 neutrons. Do you understand?
जी सर.
Similarly, if you look at the case for nitrogen, how are we going to draw its atomic configuration? We always look at the atomic number for that. Atomic number or proton number. So there are 7, which means there is 2 in the first shell, which is nearest to the nucleus, which is at the lowest energy level.
Lowest
Then
energy level.
this is
Then
the
5.
fifth one,
The last.
the last one, right? Now
Right.
it is very difficult for it to lose 3 electrons. Rather, it was difficult to lose 5 electrons. Rather, the best option is to get 3 electrons, right? So if it gets 3 electrons, it becomes 8, which is its last shell, and this last and the valence shell gets full, becomes full with 8 electrons.
सर अगर 3 इलेक्ट्रॉन दे दिए तो क्या होगा?
तो क्यों देगा? Why is it going to give? उसको तो 8 अचीव करना है ना, तो 3 इलेक्ट्रॉन दे दिए तो और डेफिसिट आ जाएगा, ये तो 2 हो जाएगा यहाँ पे.
जी.
देना तो सेंस नहीं बनता ना कोई भी. यू गेट
जी.
इट? तो
जी.
3 इलेक्ट्रॉन उसने और ले लिए ताकि वो 8 हो जाए. ये बात समझ में आई?
जी सर.
तो जब ये 8 हो जाएगा, बट इट हैज टू पे द प्राइस, क्योंकि पहले इसके पास कितने इलेक्ट्रॉन्स थे? अब अगर हम देखें 7 इसका प्रोटॉन नंबर था, तो देवर एंड 14 वाज इट्स वो, तो 7 देवर 7 इलेक्ट्रॉन्स, 7 protons,
7
and neutrons were 7 as well.
7.
But once uh, now the electrons are become have become, this stays 14, this stays 10, but
10.
there is a charge on it, 3 plus का charge आ गया इसके ऊपर. Why? Because it has gained 3 electrons. Now the electrons are 10, protons are 7, neutrons are 7. Do you understand this point?
जी.
You get it?
Yes.
The price that it has to pay is that it has become 3 positive now. And this is also called its valency. Valency. It is all, what is valency? Tendency to make bond. We're going to study this ahead, inshallah. First, I want you to understand all of this. Again, let's take another example. Let's take another example of magnesium. Magnesium, magnesium is 24 and 12. So how many protons are there? Electrons. How many electrons are there? 12 electrons. How many protons? 12 protons. And how many neutrons? 12 neutrons, right? Making sense, right? So if you make the configuration for sodium, magnesium, what is going to be the configuration for magnesium? Can you tell? G, Alishba, can you tell?
जी सर।
कॉन्फ़िगरेशन क्या बनेगी, इलेक्ट्रॉनिक कॉन्फ़िगरेशन मैग्नीशियम की क्या बनेगी? फर्स्ट शेल में क्या आएगा? हमेशा
फर्स्ट
टू
शेल में
टू
सर
आएगा
टू
ना,
आएंगे।
टू
जी।
से ज्यादा नहीं आ सकता। फिर सेकंड शेल में मैक्सिमम
आठ।
8 आ सकता है, इससे ज्यादा
8।
नहीं आ सकता। तो ये क्योंकि वो कितने हो गए, टोटल 10 हो गए। अब
और फिर नेक्स्ट में 2 आएगा।
2 बच गए। तो अब हमें ये वी आर एबल टू अंडरस्टैंड दैट दिस 2 मैग्नीशियम,
इज द लास्ट।
the last valence shell also tells us something about the group of the periodic table, that what is in which group in which group a metal is. We'll look at it laterwards. If you look at the periodic table, you will see that periodic table is divided into groups. There are 8 groups and there are periods. Periods are periods are rows and groups are columns. Right? By looking at the valence shell, the electrons in the valence shell, you can also tell in which group is it. So you can say that magnesium only has 2 electrons in its outermost shell or the valence shell. It means it is in the second group. Now it is very difficult for it to do what? It needs to achieve stability. It is difficult for it to get 6 electrons to become octet. So it is going
या
to lose 2 electrons to become an octet. So when it loses 2 electrons, minus 2 electrons, it loses 2 electrons, then it is going to be left with these two. These two are left. So 2 and 8. And 8 becomes its last shell,
लास्ट।
which is the valence shell. But the price that magnesium has to pay is what? That it gets a charge of 2 plus on it. Now, with something that has a charge, the electrons, we see the charge, it means positive charge means that the electrons are lost. How many? 2 electrons are lost. 2 electrons are lost. So 2 electrons are lost. So what is going to be the number 10?
10।
Proton is going to be 12 and neutron is going to be 12. There is no effect on proton and neutron. Why? इन पे कभी क्यों नहीं इफेक्ट आता? बिकॉज दे नेवर मूव, ये हमेशा कांस्टेंट रहते हैं, ऑलवेज कांस्टेंट फॉर एन एटम। हाँ, जब आइसोटोप्स होंगे then the number of neutrons can change. It is only the electrons which are the moving particles which are going and coming, going and coming. Okay, is this clear? Is this clear to you?
जी सर।
All right, so let's keep it till here today, inshallah.
सर
From
आई हैव टू आस्क यू समथिंग। अस्सलाम वालेकुम सर।